Hello, I'm going to do a short demo on the Wrap framework. First, we're going to start off by building the framework, and it's going to build a number of libraries and test applications from about 8 or 9,000 lines of code. We're building with the -w all to get all the warnings and treat them as errors, and we don't have any problems for warnings in the code. We built the library for the Wrap framework with the soft wrap and the copy on write, and we also built the simulator for wrap. So next I'm going to show an example program, and this is just an array update. We're going to run in the wrap tracer, and we're going to do the check wrap to make sure that all of our bounds on our application are being done. So we're going to first run this, and we'll see that, oops, we get a bunch of these warnings that in our simple test.cpp, line 14, a persistent write is not under wrap bounds. Take a look. Oh, line 14 is data of I is equal to value. We're assigning data, which is under a wrap open and a wrap close, and data is a pmalloc data, pmalloc, pfree, and pmalloc array of integers, and we're just writing to it and not wrapping that value. So luckily I have the fix right here. So we're just going to do a wrap store. And something else to notice rather quickly, that the value we're writing into the array is a sequence of characters starting at A. I'll show you that significance in a second. So save, we're going to rebuild our application. Built fine. So now we'll rerun it. And it's running in the check wrap bounds, and it ran fine. So next I'm going to show you that we can check to make sure that we're actually doing the writes to SCM. So we can run our persistent memory allocator and have it be backed by a file. So we'll just call that file SCM. We'll set our wrap implementation to soft wrap, which is coded as 6. I'll show you those options in a second. First, let's look at SCM. We'll clear it out, so it's nothing. And we'll run our simple test application and look at what it did to the SCM. What? Lo and behold, we have main memory here, and this is SCM starting at A, going through 40 characters, so 10 elements of 4 bytes each. Okay, so now we clear our SCM. We've shown that a persistent file can simulate our SCM for our implementation. So I'm going to show you the multi-threaded array application we talked about earlier. Here are the options we had on it, so it has quite a number of options. So we'll just run it under pin again. And this time we don't need the check wrap options. We already know it's okay. So we're going to just run empty array. And let's see, we'll run it. Here's our options again. We'll run it with 10 threads, 100 ints in each thread, read-write ratio of 1, wrap size of 20, 20 wraps, no delay between wraps, and we'll start off with a wrap type of soft wrap. So here are wrap type options. We can do memory check, no SCM, no guarantees, no atomicity, undo log, wrap software. So we'll just do 6 for soft wrap implementation, and we're running 2 copies of DRAM sim. So we see it's written, done then through stores, and the total wrap time to restore all your entries is 2.176,861 million cycles. So now we can set our debugs, just to show you we can do debug, set that to 1. Now we'll run with 4. 4 is copy on write. So get a little debug here, running all the reads writes for all these entries. And our total is 276,593. So, you know, about 20% bigger than the 2.1, it's 2.17. Another option, what we can do is show that we can change the implementation of the SVM by specifying this slowdown factor. So right now it's simulated default as DDR2. We'll change it just to 2 times slow as the currently simulated DRAM. So we go from a 2.17 million down to 1.70679. And we'll see that, let's turn debug off, and we'll see what copy on write. So copy on write, if it's going to be less than the 1.706. Copy on write, initializing, and it's 1.9. So as we add more threads and bigger applications, and get more use out of the alias table, that will improve the speed up. Thank you very much.